Hello friends, welcome to the video on probability. In this video we will see very basic concepts of probability and practice problem based on experimental and theoretical approach of probability, as well as events, experiments and axiomatic approach of probability. Problems based on experimental and theoretical approach of probability. A coin is tossed 1000 times with following frequencies: head 455 and tail 545. Compute the probability of each event. Now the coin is tossed 1000 times. So how many events will be there in sample space? That is 1000. Hence n of s is equal to 1000. Now when the coin is tossed 1000 times, it is given that head is obtained 455 times, hence number of events of getting head on the top is 455. Similarly, n of t is 545. Hence, probability of getting head is equal to n of h upon n of s, that is 455 upon 1000, which is equal to 0.455 upon 1000. Similarly, probability of getting tail is equal to number of events, that is n of t upon n of s, is equal to 545 upon 1000 is equal to 0.545. The record of a weather station shows that out of past 250 consecutive days, its weather forecasts were correct for 175 times. What is the probability that on a given day it was correct, and what is the probability that it was not correct on a given day? Now, the record of a weather station shows that out of 250 consecutive days, that means for how many days it was recorded, or for how many days we are taking the records into consideration, is for 250 consecutive days. Hence, n of s is equal to 250. Now, the weather forecast was correct for 175 times, that is for 175 days it was correct. So, number of events on which forecast was correct, that is n of correct, is equal to 175 times. Hence, probability that on the given day the forecast was correct is equal to n of correct upon n of s, that is 175 upon 250 is equal to 7 by 10. Now, probability of getting a correct forecast was 7 by 10. Hence, probability of getting the forecast which was not correct on a particular day, which is equal to 1 minus 7 by 10, that is 3 by 10. The percentage of marks obtained by a student in a monthly unit test are given below in the table, that is unit test 1, 2, 3, 4, 5, and percentage marks obtained are also given as 69%, 71%, 73%, 68 and 74%. Based on this data, find the probability that students gets more than 70 marks in a unit test. Now, there are 5 unit tests. So, we can say that n of s is equal to 5. Now, in how many tests that particular student has got more than 70% marks is test 2, test 3 and test 4, that is 71%, 73% and 74%. So, n of 70 plus marks is equal to 3 and n of s is equal to 5. Hence, probability of the event of getting 70 plus marks by that particular student is equal to n of 70 plus marks upon n of s, that is 3 upon 5 is equal to 0.6. Now, problems based on outcomes and sample space. If a coin is tossed 2 times, describe the sample space associated with the experiment. Now, we know that if we toss a coin, we can either get head or tail. So, if we toss one coin, then there will be 2 events in the sample space. Now, the same coin is tossed 2 times, hence total number of events in the sample. So, sample space can be first time head and second time also head, first time head then tail, first time tail then second time head, or on both the times we can get tail. Hence, sample space is equal to HH, HT or TH and TT, as in there are 4 events in the sample space. A coin is tossed and then a die is thrown. Describe a sample space for this event. Now, a coin is tossed. So, number of events in the sample space will be 2, and after that a die is thrown. So, number of events in this sample space is 6. Hence, total number of events in this sample space is 2 into 6 is equal to 12. So, we can expect 12 different outcomes. Now, we will define the sample space. So, suppose on the coin you have got head, then on the die you can have any number in from 1 to 6. So, H1, H2, H3, H4, H5 and H6. Similarly, on the coin you can have tail, and then on the die any number from 1 to 6. Then T1, T2, T3, T4, T5 and T6. Hence, there are 12 events in the sample space as H1, H2, H3, H4, H5, H6, T1, T2, T3 and T4, T5 and T6. A bag contains one white and one red ball. A ball is drawn from the bag. If the ball is drawn white, it is replaced in the bag and again the ball is drawn. Otherwise, a die is tossed. Write the sample space for this experiment. Now, let us suppose the first ball which is drawn from the bag is white. Then it is given that if the ball is white, then it is replaced in the ball, then again a ball is drawn. So, if the first ball is white, then second ball can be either white or red. So, in the sample space, initially we need to write either WW or W red. Now, if at all the ball is red, then the coin is tossed. Then, if the ball is red, then the die is tossed. So, after red, we can have 6 different possibilities for a die. Hence, it would be R1, R2, R3, R4, R5 and R6. Hence, total events in the sample space are WWWR, then R1, R2, R3 or R4, R5 and R6. Problems based on event, occurrence of events and types of events. Now, 3 coins are tossed. Describe the following events associated with this random experiment. A is getting 3 heads, B is getting 2 heads and 1 tail, C is getting 3 tails and D is getting a head on the first coin. Now, the question is, which pairs of the events are mutually exclusive, which events are elementary events and which events are compound events. Now, 3 coins are tossed once. So, there are different events are given. A is getting 3 heads, B is getting 2 heads and 1 tail, C is getting 3 tails and D is getting a head on the first coin. Now, we will define each event first. So, A is getting 3 heads, that means A will be equal to H, H and H. B is equal to getting 2 heads and 1 tail. So, it can be either heads on the first 2 coins, that is HHT, or head on first and third, that is HTH, or head on other 2, that is TH and H. Now, C is getting 3 tails, such as C is equal to T, T and T, and the last one D is equal to getting a head on the first coin. So, it would be now getting a head on the first coin. So, there are different possibilities for second and third. So, we can have either HHH HHT, HTH or HTT. In all these 4 events, on the first coin head is there and different possibilities for second and third coin. Now, so how many events are there in sample space? 3 coins are tossed, so 2 into 3 is equal to 6. Now, first question is which pairs of events are mutually exclusive? So, we can observe that A and B are mutually exclusive. Similarly, A and C is also mutually exclusive and B and C is also mutually exclusive. At the same time, C and D is also mutually exclusive. Which events are elementary events? Elementary events are A and C, where only one outcome is possible. And which events are compound events is, so as A and C are elementary events, B and D is compound events. A card is picked from a deck of 52 playing cards. What is the sample space of the experiment? What is the event that the chosen card is black face card? Now, a card is picked from a deck of 52 cards. So, how many events will be there in sample space? That is 52. So, sample space is a set of all 52 cards. Now, what is the event that chosen card is black face cards? Now, we know that king, queen and jack are the face cards. So, in a set of cards there are total 12 face cards. Out of these 12 face cards, 6 cards are black, that is black spade king, black spade queen, black spade jack. At the same time, black club king, black club queen and black club jack is also black face card. Hence, there will be 6 possible combination of getting a black face card. Problems based on axiomatic approach of probability and probability of an event. A die is thrown, find the probability of getting a prime number, 2 or 4 and a multiple of 2 or 3. Now, a die is thrown, hence in the sample space there will be 6 events. Now, we need to find out probability of getting a prime number. So, how many numbers are possible? We know that out of 1 to 6, 2, 3 and 5 are prime numbers. So, there are 3 possibilities. Hence, probability of getting a prime number is 3 upon 6, that is 1 by 2. Then we need to calculate probability of getting 2 or 4. So, we can either have 2 or we can have 4. Hence, it would be 2 upon 6, that is 1 upon 3. And probability of getting a multiple of 2 or 3. So, we can either have 2, we can either have 4, we can either have 6 or even we can have 3. That means, there are 4 possible outcomes. Hence, probability is equal to 4 upon 6, that is 2 upon 3. A bag contains 6 red, 4 white and 8 blue balls. If 3 balls are chosen at random, find the probability that 1 is red and 2 are white, 2 are blue and 1 is red, 1 is red. Now, there are 6 red, 4 white and 8 blue balls in the bag. That means, there are total 18 balls in the bag. So, how many events are possible in the sample space? Now, out of these 18 balls, 3 balls are to be drawn. Hence, n of s is equal to 18C3, that is 18 factorial upon 15 factorial into 3 factorial. So, upon simplification, we get 18 factorial as 18 into 7 into 16 into 15 factorial upon 15 factorial into 3 into 2 into 1. Now, this 15 factorial and 15 factorial will get cancelled. So, we have 18 into 17 into 16 upon 3 into 2 into 1, that is 816, the 816. So, in sample space there will be 816 events. Now, the first event is 1 is red and 2 is white. So, in how many ways we can choose? One red ball is 6 C1 ways and other 2 are white. So, out of 4 we can select 2 balls. Hence, event A will have number of possibilities as 6 C1 into 4 C2, that is 6 factorial upon 5 factorial into 1 into 4 factorial upon 2 factorial into 2 factorial, that is 6 upon 1 into 4 into 3 into 2, that is 36. Hence, probability of A is equal to n of A upon n of S, that is 36 upon 816. So, simplified form is 3 upon 68. Now, next event B is 2 are blue and 1 is red. Now, how many blue balls are there? There are 8 blue balls. So, 8 blue balls we can select in 8 C2 ways and 1 is red. That 1 red ball we can select in 6 C1 ways. So, total number of ways for the event B, that is 2 are blue and 1 is red ball, is 6 C1 into 8 C2, that is 6 factorial upon 1 factorial into 5 factorial into 8 factorial upon 2 factorial into 6 factorial, that is 6 upon 1 into 8 into 7 upon 2 is equal to 168. Hence, P of B is equal to n of B upon n of S, that is 168 upon 816, which is equal to 14 upon 68, that is again simplified up to 7 upon 34. And the last one is 1 is red. Now, when one ball is red, other 2 balls can be of any color, that is other 2 balls will be either white or blue. Hence, one red ball can be chosen in 6 C1 ways and 4 white and 8 balls. So, other 2 balls can be chosen from this 4 white and 8 blue balls, that is 12 C2 ways. So, 6 C1 into 12 C2 is equal to 6 factorial upon 1 factorial into 5 factorial into 12 factorial upon 2 factorial into 10 factorial, that is 6 into 12 into 11 upon 2, that is 396. Hence, probability of C is equal to 396 upon 816, that is 99 upon 204, which is equal to 33 upon 68. Find the probability that in a random arrangement of letters of the word social, vowels will come together. Now, in the word social, how many letters are there? There are 6 letters. So, total number of arrangements of the letters of the word social is 6p6, that is 6 factorial. Hence, we can say that n of S is equal to 6 factorial. Now, what we want is, in the arrangement should be in such a way that all the vowels should come together. Now, how many vowels are there? There are 3 vowels O, I and A. So, in this arrangement, out of 6, 3 vowels should come together. So, total number of arrangements in which vowels are coming together is 4p4 into 3p3. Now, why 4p4? Because out of 6, 3 vowels and remaining 3 are consonants. So, 3 consonants and 1 unit of these vowels will be arranged in 4p4 ways and 3 vowels are arranged in between amongst them in 3p3 ways. So, 4p4 into 3p3, that is 4 factorial into 3 factorial ways. So, the probability of this event is n of A upon n of S, that is 4 factorial into 3 factorial upon 6 factorial. So, 4 factorial into 3 into 2 into 1 upon 6 into 5 into 4 factorial. Then 4 factorial will get cancelled. So, 3 into 2 upon 6 into 5, that is 1 upon 5. A and B throw a pair of dice. If A throws 9, find B's chance of throwing a higher number. Now, A and B throw a pair of dice. So, number of events in the sample space is 6 into 6, that is equal to 36. Now, if A throws 9, the event B should be such that B is having a higher number. So, B can either get 10, B can either get 11 or B can either get 12. Now, in how many ways B can get number 10, that is he can get either 4 and 6, 5 and 5, 6 and 4. Then he can also get 11. So, 11 can be obtained with the combination of 5 and 6 or 6 and 5, and he can also get 12. So, there is only one possibility of getting 12 is 6 into 6. So, in event B, there will be possible options are 4 6, 5 5, 6 4, 5 6, 6 5 and 6 6. That means total 6 possible combinations are there. Hence, probability of B is equal to n of B upon n of S, that is 6 upon 36, which is equal to 1 upon 6. So, in this video we have seen few practice problem on basic concept of probability, experimental and theoretical approach of probability, events, experiments and axiomatic approach of probability. Thank you.